Working? Yeah. Okay, I think we can start, and when the technician comes in, we can let a few minutes to make sure the camera is recording and everything. So, good morning, everyone. Thank you for being here. I'm Fran Martin. I'm product manager at EarthPulse, and I will give in this session about the EOTDL. This is a tutorial on crafting training datasets and developing machine learning models using not only the EOTDL, but some other tools which are in the ecosystem and of the EOTDL framework. First of all, a few questions. How many of you work with AI for Earth observation, creating datasets, training models, and so on? Okay, nice, quite a few. Okay, I'm asking this because I want this tutorial to be like a monologue of me speaking like for 3 hours, because if then it won't take so much. So I expect you to be an interactive session, talking a lot, and so on and so forth, and gaining insights together. Okay? So, first of all, I think there is the coffee break at 10:13, if I'm not wrong, and then it will continue until 12. So, as mentioned, I'm Fran Martin. I'm the product manager at EarthPulse. EarthPulse is a tech startup based in Barcelona. What we do basically is to transform Earth observation data into insights that our clients can use to make data-driven decisions, both for saving money or to generate money. In this sense, I am the product manager, which means that I am in the intersection between the data itself and users. So I take care of matching the correct data, the correct solutions with the user to make sure we create something that actually solves a pain point from our users' point of view. And actually, this is a position I love because it allows me to speak a lot with people, with clients, and understand where there are pain points and to create solutions that cover these necessities. So the objectives of this workshop is to explore the EOTDL, the Earth Observation Training Data Lab, explore the full workshop of the full workflow of using this tool, from exploring dataset, accessing them, creating them, also training machine learning models and ingesting these machine learning models, and to demonstrate how the EOTDL works and to show how the EOTDL is an open and collaborative platform that our goal here is to lower the barrier of developing AI models, to democratize the accessibility, the access of these analytics, of Earth observation analytics, to all the people. Okay? Before everything, I always like to start with the problem space, so with some short histories. This is Alex. This is a student. Alex wants to start in the AI for you field. He's a student passionate about Earth observation and wants to learn about Earth observation and AI. He wants to train first model, maybe experiment, learn, create even his first data set. But there is a problem. Is that he doesn't know where to start. I mean, there is a lot of data fragmentation, as you may know, a lot of different websites where Alex can go to check data sets, to check models, and he doesn't know where to start. So finding these data sets takes time. Labeling data, if you label data sets, take a lot of time, consumes a lot of time, can feel overwhelming, and training model from scratch also seems to be quite difficult if you are not into AI. So Alex is stuck there, and his curiosity is at the risk of fading. But luckily there is a solution, which is the EOTDL, which is the Earth Observation Training Data Lab. So in a few clicks, Alex discovers a cloud repository with over 100 curated Earth observation data sets, ready to use models, pipelines, a cloud-based workspace. So in few hours, Alex is not just ready for AI for EO, but he's training models, he's testing ideas, he's hosting these models because maybe Alex doesn't have like a powerful machine with a lot of capacity with terabytes of data, but EOTDL has. So EOTDL lowers these barriers and transforms curiosity into action and empower Alex to enter the AI for EA sector and innovate without barriers. And this is what we are going to see in this workshop. So this is the QR to go to the GitHub repository. If not, here you have the URL. This is at my GitHub page, fmarip, and it's workshop EOTDL bits 25. Can give you a bit of time there. Okay. So this is the GitHub repo and all of the notebooks for this tutorial. This tutorial will be mainly based on notebooks, on Jupyter notebooks that you can open in your favorite IEM code editor. Or if you want, you can simply go through the session and see me do the demonstration. So let's start from the beginning. So what's the EOTDL? The EOTDL is an initiative, it's an open platform funded by the ESA. We are in the leaders of the consortium that we'll see later on the other members. But the goal of the EOTDL is being this centralized repository where everyone or anyone can go there, explore datasets, ready-to-use datasets for AI for Earth observation, even ready-to-use models, pipelines. So EOTDL overcomes several challenges, such as the lack of these datasets, which is one of the main barriers of democratizing the AI for EO. So creating these datasets is costly. This data can be very, very large. It's costly, it's complex, requires a lot of manual labeling. So you need to actually know about the data. So the EOTDL tries to lower this barrier. So what is the EOTDL? As mentioned, it's a cloud-based repository with more than 100 datasets, curated datasets covering different EU applications, from classification to object detection to segmentation and so on and so forth. It has even different pre-trained machine learning models and tools for dataset generation, curation, and ingestion. So this is the agenda. This is what we are going to see in this tutorial. First of all, an introduction to the EOTDL. Then we'll see how to explore and stage datasets and pre-trained models. Then we'll try to ingest a dataset. We'll see how the EOTDL uses the stack specification, how to work with private datasets in the EOTDL, how to create a dataset using the EOTDL tools. We'll try to train a machine learning model and ingest it to the EOTDL. And last but not least, we'll see how we can contribute to the EOTDL. So you can follow the tutorial in two ways. You can simply watch the live demonstration and run the notebooks later at your own pace if you want, or you can follow interactively in your own machine. So first of all, you need to register as a user in the EOTDL. We'll see later. And then you need to clone this repository, install Python, and this repository is using UB for Python package manager. I don't know if many of you are aware of UB, or do you know what is this? So UB is like pip or conda, but with steroids. So it's much, much, much faster. It allows us to simply, with one command, to synchronize and create a Python environment. I can show you here. So this is UB, as you can see, is from 10 to 100 times faster than pip. If you want, you can follow the tutorial using this. If not, as said, you can simply follow the live demonstration. But what we can do with UB is that simply with a UB sync, with this command, it will create a new Python environment, which will be exactly the same as the one I am using. So with that, we cover all of these. I'm sure you have all of these problems and issues with Python dependencies that can be a pain a lot of times. So with that, you'll have the exact environment with exact versions in your computer, and you can make sure that you will be able to follow the tutorial. And another option is to use the EOTDL workspace. I'll show you later, because the EOTDL has a cloud workspace with a Jupyter Lab, and you can upload there your notebooks and play with them and run them in your own workspace. I'll show you later how you can do it. Here you have the QR to join the EOTDL Discord channel. So we invite you to join the Discord channel to ask questions, to stay updated about the EOTDL, connect with other participants, and receive updates about this. So as mentioned, this is a Discord channel, and we invite you to join. So let's go to the first notebook. Can you see it good, or maybe I can make it a bit bigger? Bigger? No. Yeah. Better? That way? Is it okay, or? Yeah. Okay. So, well, I can give you a bit of time if you want to go through the notebooks. First of all, before starting, many of you are already working with AI for EO. Which are the main limitations you struggle with when you work with this data? Maybe creating the data sets, hosting them, labeling the data sets. Tell me a bit about this. Don't be shy. Let's make it. No? Okay. We can go through other questions later. So, I already gave some background about the EOTDL, but I won't repeat. So one of the most limiting factors of AI for you applications is the scarcity of suitable training datasets. So training datasets, as you may know, is the dataset used for training these machine learning models to perform a specific task. And right now, one of the main barriers is gathering the data, gathering the imagery, and labeling this data in a fast way. So there are some techniques that can help with this task, for instance, transfer learning or unsupervised learning or data augmentation. But annotated data, these labeled datasets, is always required for fine-tuning and validating these AI models. So generating these training datasets is time-consuming, time-expensive. Data access is usually limited. There are a lot of different data providers you can go through. Some of them are commercial providers, or some of them are not as straightforward as we might desire. Because if you work with Earth observation, as I assume most of you do, I think we can all agree that there are a lot of different data providers or sources where we can go through to get and gather all of this data. So there are a lot of different barriers here, and the goal of the EOTDL is to address this limitation and gaps for working with machine learning, training data in Earth observation. So this is a set of open source tools, because all of this is open source. Then I'll go through the GitHub, and you can go there to take the tools you need, from data access to data curation to sharing datasets to improve and label datasets. Everything is open source, and you can go there and you can contribute. So the EOTDL is a project funded by ESA, developed by us, by EarthPulse as project lead, and there are other members in the consortium, such as Synergize, maybe you know them from Sentinel Hub. Then there is EOX, Broadman Consult, and Space Tech Partners. This is the landing page. Then we'll go through the page, through the user interface, no worry. So the EOTDL is an open source software, and users can access the data for the dataset creation, selecting data sources, time range, areas of interest. Metadata curation is done following the stack specification. How many of you work with the stack specification or know what is it? Okay, great. Maybe we can go through a bit of the stack specification. Well, there is a notebook later. Then there is some engineering tools here in the EOTDL for feature engineering, labeling, and so on. And then the EOTDL, as we'll see later, is accessible through different levels. From the user interface, which is the easiest one, from the API, from the CLI, and also the Python library. So, who is this for who is the EOTDL for? The EOTDL, as mentioned, is free, is open source, and is available to everyone. So you might find it interesting if you are above these users, or even if you are not here, you can find it interesting. So you are a data scientist or machine learning engineer working with Earth observation data, so you can use the EOTDL to create, share your data sets, even create and share your models, pick ready-to-use models. So there are different options. You are a domain expert, so from forestry, agriculture, and you want to explore how Earth observation can give you advantages in your field, so you can explore, try and download models for your custom domain. You are a developer and you simply want to contribute to the project. So as mentioned, this is open source. You can contribute to the code base. You can even share or add more data sets, more models, documentation. Or you are a student, as we've seen before, as Alex, and you want to learn about AI for EO. You want to jump in this field. So this is a very good starting point. So again, we'll see later. We have the Discord chat and GitHub that we will see later. So these are some questions that I already made before. It's too early in the morning, so maybe we can wait a bit to start the chat, no worry. So let's go to the second notebook. Everything fine until this point? Any comments or questions, whatever? Okay. So let's start by exploring and downloading datasets and models from the EOTDL. Okay, as mentioned, there are different layers to access the EOTDL, from the user interface, which is the easiest one, the API, also there is a command line interface, the CLI, and the Python library. So we can start with the user interface, which is the easiest way to get started with the EOTDL. So let's go there. You can see it. Yeah, I think so. Okay, so this is the main page of the EOTDL. It is simply EOTDL.com. And here we have all of the features and functionalities of the EOTDL, everything we can do through other interfaces. This is the easiest way to interact with the EOTDL. Here, if you go down, you'll see tutorials, data for creating datasets and model, for data access, for a stack. If we are going to events, recent datasets that have been uploaded, popular datasets, which are the which are the most downloaded datasets, which are the top contributors. So we can see here, well, mainly Earthpool, so Juan, which is our CTO, and myself. Then we have recently uploaded models, popular models, and again, the top contributors to these models. Post, and this is quite important. This will be also shared in at the end of the session, the tutorial. But you have some feedback when we finish this tutorial, you have anything you think could be worth to share with us about the EOTDL, something you enjoy or something you miss or whatever you think is relevant, please, you can scan this QR and go through a short survey. Okay, here in the first thing we can do here in the user interface is to sign in. So as I am already signing it, this is quite for me, but it's quite quick for me, but it can take some time. For you, it's just to sign in, so it's a quick process. And what we can do and what we can see here. First of all, we can go through the GitHub. So, as I mentioned, the EOTDL is completely open source. There are a lot of different tools. There is the Python package. There is the API. So this is the GitHub repository of the EOTDL. Here you can find, as we've seen before, what's the EOTDL, who's the EOTDL for, why there is this initiative from the ESA, how to install it using the documentation. Here is using pip, but you can use it. You can install it also using UV. So there is no under the hood. UV uses pip, so there is no problem with compatibility there. And here we can see other usage examples, tutorials, and how to contribute. So actually, if you go there and you go to the issues, you can see what we are currently working on. So there are a lot of open issues. Please feel free to open more issues if you think you find a bug, you find something, a feature you miss, whatever you think is relevant. Please create an issue there and share this information with us, and we'll take care of taking a look for that. So this is the GitHub repository. Here we have also the documentation. So this is another guide that we can go through if we want to get started with the EOTDL. So from installation, using pip install, authentication, using the CLI, we'll see this later, how to use cloud resources, then how to go through datasets. So as mentioned, the main functionality of the EOTDL is to host and share datasets and models. So here we can see how we can explore datasets using the user interface, the CLI, the library, or even the API, because this is something we are not going to see in this tutorial, but everything you can do with the CLI and the library can also be done using the API. So here you have the documentation, and so please feel free to try or do whatever you want to try. So even more, I can open the API. So this is the endpoint of the API. You can go there /docs, and here you'll find all of the different endpoints we have here for the EOTDL. So you can go, check the endpoint, check the needed parameters, and start playing or trying it. Okay, so this is another way of interacting with the EOTDL, but as mentioned, we won't see this in this tutorial. So, coming back to the EOTDL user interface, so let's go to the funny part. So we go to datasets. We have here different pages. We have datasets, models, pipelines, workspaces, even more tutorials. So we've done several tutorials here for the EOTDL. So the Living Planet Symposium, last fill up, last bits. So all of since the last bits, EOTDL has changed a lot. So please refer to the most updated, up-to-date tutorials. And here we have different applications, again, under the EOTDL framework that we'll see during this tutorial, such as the Cloud Workspace, Scaneo, and PyTorchio. But let's go to datasets. Here, as you can see, we have actually 100 datasets. Here in the EOTDL, the number is growing every day as we find useful data sets or users jump in the EOTDL and want to create a data set and share with them, make them public. So here we have a lot of different data sets. So for different use cases, we can even filter them per application. So maybe, for instance, for land cover, for flood detection, we can even filter by the data use, Sentinel-1, Sentinel-1, Sentinel-2, Airbus data. So we have different tags we can use to filter, even for tasks. So image classification, we can look if we want a data set to train a model for image classification, we can simply use the tag, or for the segmentation, object detection, and so on and so forth. So what we can do, we can go there, we can click one of the data sets, and what we'll see is this. So we'll see some metadata about this data set. This is some information. We can see the description of the data set. We can see the authors, the license. We can see the source. And we can see how to stage the model, which at the end means downloading the data set and getting the data set locally. So this is directly the CLI command. And what we can do for here, we can see the files that compose this data set. Something important to mention is that right now, the EOTDL does not any kind of automatic curation for the datasets. So it's the responsibility for every user to make sure that they use the dataset they need and they use a dataset which is correctly curated. Okay? So we can find datasets that are amazing. We have datasets of terabytes of data which are very good curated and very good labeled. And there are other datasets that are simply a zip file, and you need to download the file and zip it and work with that. So there are different types of datasets, and as mentioned, you as users need to make sure you are using the correct dataset for your needs. But from here, what we can do is to simply, we can search from the files, and we can download it directly from there. Here from the user interface, we need to go file by file, but we'll see how using the CLI or the Python library, we can download the full data set and staging it locally if we want to do so. So this is for data sets. Another thing important is that versioning. So the EOTDL takes care of the versioning. It's like working with Git. So I'm sure many of you work with Git. So at the end, it's about versioning the data set. If you share a dataset version and then you want to do some changes and you share again the dataset, you ingest it again, the EOTDL will take care of versioning and maintaining a track of the different versions of your dataset. So in case you want to go back because you forgot something, you can go back and you can navigate through the different version of your dataset. Then we can go through models. So this is also another very interesting part, and is the same as we've seen for datasets, but we have here for models. So we have ready-to-use models that anyone can go there. You can check, you can filter by use case, by data, or by task, and you can directly download the model and use it. So for instance, let me check, we have the CloudSend 12L2A, which is a model for cloud segmentation and cloud detection. This is a model that works amazingly well, so you can go there, you can check the information, because here you have both the model and the dataset. Thank you. So this is the dataset which was used to train this cloud detection model, and here we have, again, some information, the metadata, license, source, and here we have the file. So this is the model. We can simply click. We can see the checksum, the size, and the path, and we can download it. And with that, we can start using this model, as we'll see later. Obviously, if you know how to use this model, the Python packages, and so on. Now we have workspaces. So I'll start this one. We'll see how to work with that. But at the end, this is a cloud workspace EOX is providing for the EOTDL. So you can go there, and as we'll see later, you can upload the notebooks of this tutorial or other notebooks if you want, and you can go there and run these notebooks in this space, in this workspace. So maybe you don't have like a powerful machine with GPUs or wherever you need to train models or to host the datasets. You can use this cloud workspace. We'll see how to use it later. Okay. Everything good from this point? Questions or comments, suggestions? What do you think about the user interface? There is something you may miss, maybe difficult to find models or data sets, or what do you think about this? Yeah. That's something we tried. So at the end, the user experience is very important there. It's not just about having a lot of data sets, which I mean, it's amazing, but also making these data sets actually findable for everyone. So that's something we put a lot of care there. Everything fine? Shall we continue? Okay. So this is exploring datasets and downloading datasets and models using the user interface, but we can do the same using the CLI. So we've seen there the command line, we will see the user interface, and we can use the command line interface just with CLI commands. So here we have some comments in the notebook in case you didn't install it or synchronize the UV environment. If you don't have UV, you can simply do so. This is the same. It will use pip instead of UV. UV is much faster, but feel free to use wherever you need or is suitable for you. At the end, other option is to do UV pip install, which is actually the same. So UV, as mentioned, uses pip under the hood. So once installed, you can execute the CLI and you can execute EOTDL commands. And you can check, first of all, help, and we can see which are the different commands that we can check. So if we run the EOTDL help, we'll see the options and which commands we can use for the EOTDL. So here we have different options. So for instance, for install completion for the current shell, show completion, help, which is the command we just used, and the different commands. So we can check, for instance, which is the current EOTDL version. We can get the EOTDL API URL to interact with this URL. We can log in from here, which is the first step we need to do. And we can interact with datasets, models, the EOTDL stack API, and the pipelines, which is still something. Pipelines is something that is still in experimental, so that's why we won't see it in this tutorial. So some commands we can do. So we can do the EOTDL version, and we can check that this is the most up-to-date EOTDL version. Also, we can go through the datasets. So this is the EOTDL datasets command, and if we again use the help option, we'll get the different commands that we need to that we can do and we can use to interact with the EOTDL datasets. So there are a few commands, and these commands are the same across datasets and models because we try to maintain like a logic workflow, try to lower as much as possible the barriers and the friction, so you can interact the same way with datasets and with models. So what we can do here? We can, for instance, ingest a dataset to the EOTDL, which means you have your local dataset and you want to upload it to the EOTDL. You can retrieve the list of all the datasets that you have in the EOTDL. You can get We can see both stage or get, but at the end it's downloading a dataset from the EOTDL. And if we want, obviously, we can delete a dataset if it's owned by us, obviously. So we can explore datasets with the following command, with the EOTDL datasets list. Again, if we use the help option, we can see which are the options different commands and options we can use through the data to get this list of datasets. So we can use, and we can filter by name, we can limit the number of results. Here we have some examples, so for instance, EOTDL list, EOTDL datasets list, or EOTDL datasets list, providing a name, your model or your dataset, and a limit. And here we have the options, as mentioned. We'll see how we can work with private datasets in a next notebook. So if we run EOTDL dataset list, we get the full list of datasets we've seen before. So the same we've seen in the user interface, we can see it here in the CLI. And as mentioned, we can filter obviously by name. So if we use the name of Eurosat, which is a dataset we use a lot for workshops. It's a straightforward dataset to use, very easy to understand. It's not so big, so it's very easy to use in this and to play with in these kind of tutorials. So we use a lot of this Eurosat dataset, and we'll use it later. So actually, as you see here, we use this dataset and we upload a lot of different versions for different workshops. We have a small version, so we can filter, and we'll see all of the Eurosat datasets that we have in the EOTDL. Before the first time you run the command to get or ingest your dataset or your model, you'll need to authenticate through the CLI. Okay, so if you have done it through the user interface, then you need to do this again to make sure you are authenticated if you want to use the different features that the EOTDL offers. So again, if we use the help command, the help option, we can see that we can log in or that we can log out. So if we run EOTDL auth login, we can see that we are logged in. I am logged in, obviously, with my email and with my account. So let's go with downloading or staging datasets. First of all, if we run the help option again, the command is datasets get, with the help option to get all of the information and different options we can use for downloading datasets. We can use different options. So by default, if we don't provide a path to downloading a dataset, it will download to the shared your default folder in EOTDL datasets. You can provide a version. So as mentioned before, the EOTDL has versioning across datasets and models. So you can download a specific version of the dataset or the model. You can download by asset, because as we'll see later, the EOTDL, when you ingest a dataset or a model with the EOTDL, it creates a catalog, a stack catalog, and it creates an asset for every item in the dataset, and you will be able to filter and to only get one asset from the dataset if you want, or if you don't want to download the full dataset, you can check and you can filter and you can work asset by asset. Then you can use force, which I think it's pretty obvious. It will download again the dataset, even if the file already exists, and verbose, it will print the progress of the download. So here we have some examples. And here, what we can do is to run EOTDL datasets get Eurosat RGB, which is the RGB version of the Eurosat, and version 1. We run this, it will download. We'll see here that the dataset already exists in this path, in this directory, and we can see here. So to force download, we should use force. So with that, we have downloaded the dataset. It's important to mention that here we are not downloading like the full dataset, but we are downloading the metadata. If we want to download the dataset, we'll see it later how to do it. We need to add the asset flag. So by default, all the datasets will be staged to your home cache EOTDL datasets folder, and you can change the path where you want to stage the dataset using the path argument. So here, we run EOTDL datasets get Eurosat RGB, version 1, and the path to data. And if we go there, we can see that it downloaded, as I was mentioned, the catalog, which is the dataset metadata, and the README of this dataset, which is the Eurosat RGB. Here we can see the same metadata and the same information we've seen before. So the license, the source, a thumbnail, which is pretty useful for giving some snapshot in the user interface, so it's not just blank. And some information here and some description you want to add to the dataset. Obviously, the more information you provide to a dataset, the better, because it will be more representative for other users, will know better how to use this dataset, how it has been generated, and so on and so forth. But again, as mentioned, the EOTDL by itself does not any data curation. It's something that has to be done by users. Okay. Then, as we've seen, you can choose a particular version to download the dataset with the version argument. If you don't specify a version, the latest version will be downloaded. But with that, with this flag v1, you can specify the version of the dataset. And the same we see here. If we try to re-download the dataset in a path that it already exists without the force argument, it won't deny it will deny the download. Okay. As mentioned, the get command by default will only get and will only download the dataset metadata we see here, the README and the catalog. The README contains some basic information about the dataset. And the catalog version parquet contains the stack metadata for the dataset, including the links to the assets. Okay? So if we open the catalog using GeoPandas or Pandas, we can see there that this is the asset. As this dataset is just a zip, we can go to a EOTDL to see it. We go there to dataset, and we filter by Eurosat RGB. We can see that the dataset itself is just a zip. So that's why we only have these stack items for the zip. Then later on, we'll see how we can download the dataset. We can play a bit with that. We can train a model. And we need to unzip this dataset. Okay? But we can go directly there from the user interface and download the full dataset if we want. The CLI is another option. What else? Okay, this is important. As we just seen, that by default it just downloads like the metadata of the dataset. If we want to get or to stage all the data at once, so the full dataset, we can do it using the assets argument. So it's simply to add this A flag, and if we run it, we see that this is staging all the assets. In this case, this is a zip, and it's not so big. It won't take so much. Here we are. And we can go to the path, and we can see that it has downloaded the zip, the dataset. So we have staged, we have downloaded the dataset locally. We can check it here from the notebook. And as mentioned, working with models is pretty much the same. So we run the EOTDL models help option. We'll see, as mentioned before, that the commands are the same. So we can ingest a model to the EOTDL. We can retrieve the list of all the models. We can download the models, and we can delete them. So going through the same workflow, what we can do here is to run EOTDL models list, and we'll see the same options that we've seen before for datasets. So we can filter by name, we can limit, and so on and so forth. So if we run EOTDL model list, we'll get here the full list of models that are in the EOTDL. We'll see here the list. This is the same list that we've seen in the user interface. And for staging them and downloading these models is pretty much the same. So if we use the help option, we will see the same options and the same commands as per datasets. So we can go there and we can say, okay, we want to download the road segmentation model. Here, I want to download the model in the data folder. I want to download all the assets, and I want to force the download to make sure I download everything. So running this command, it won't take so much, as I think that this model is not so big. So the road segmentation model is a model for extracting roads from Sentinel-2 imagery. And as we see here, if we go to data, road segmentation, here we have the README of this model, the metadata. So these have been trained by Juan, by the Earthpool CTO. This is some information. This is an Onyx model for road segmentation. And here we have the Onyx file. So this is the model itself. Everyone can go there, can pick the model, and can start using the model. Here Juan added the source. So if you want to check how this model has been trained, you can go there. So take a look. I think it's this. No, maybe not updated. Okay. So this is how to explore datasets, how to stage them, and how to download it. We've seen how we can download models using the user interface and the CLI. We'll see how to ingest these datasets and upload datasets to the EOTDL in the next notebooks. But another option, another interface we can use to download models and to interact with the EOTDL datasets and models is the Python library. So everything that we've done so far with the CLI or with the user interface is enabled through the Python library. So this is the core of the EOTDL. So when installing the CLI, you are automatically installing also the library as well. So there are some functions, a lot of functions there for downloading, staging, and feature engineering of the dataset. So first of all, we can, for instance, check the version. We can do the same that we've done before using the CLI. So we can import the retrieve datasets function. And with that, we'll check the length of the datasets. We can retrieve the list of datasets, and we can filter by name, by Eurosat. So everything we've done so far using the user interface and the CLI, we can do the same with this Python library. And obviously, you can stage datasets as well. So here, you have the stage dataset, and it will do the same as the get command from the CLI, but using the Python library. So here, we are staging the Eurosat RGB dataset in the default folder. Here, we are saying, OK, which version do I want? Do I want to force and re-download the dataset? If I want, I can provide a path. As this, so everything we've seen using the CLI, we can do the same using the Python library. Here, what we are doing is to stage a particular asset. So we are retrieving the links from this dataset. So we can stage just a single asset of the dataset. And here, we are getting some information about these assets. As mentioned, it is using a stack specification. So here, we can go item by item in the dataset and check, for instance, the checksum. We can see here the ref. So this is the reference of the dataset in the API. We can check the size, timestamp, when these data have been uploaded. So a lot of different information. We can check this asset per asset. So this is the same. So as mentioned, the CLI is built on top of the library. And we can do exactly the same, but for models. So the nomenclature and the syntaxis is quite similar. So instead of retrieve datasets, is retrieve models. And the same, we can get the list of models we have here in the EOTDL using the Python library. We have, I think, 34 models. We can stage the model. So again, here we can stage and download the road segmentation model, forcing to download to the path, to the data directory, and assets true means that I want to download all the items that this model contains, which at the end is the Onyx file. If we run this command, we can see that we have downloaded everything. Okay, so in this section, we've seen how to explore data sets and models using the different interfaces of the EOTDL. So some questions I like to ask is that which tools or websites do you currently use to look for data sets or models? If you do you struggle with that? And why do you use Hugging Face? Maybe because it's the most. Mhm. Mhm. Okay, nice. Yeah, I mean, we are aware of, obviously, of Hugging Face, and actually I think that the biggest data set that the ESA released, it's about 40 terabytes, I think, and it's here in Hugging Face, but not even with us, the TIFFs, but with the Parquet files, because, I mean, Hugging Face has a lot of capacity. The point is that, as far as I know, like Hugging Face is like more general, not only for Earth observation, right? So our goal here with the EOTDL is to centralize only for Earth observation tasks. So it's kind of, as you can see, like a Hugging Face, but for Earth observation. Obviously, Hugging Face has a lot of different features that EOTDL doesn't have yet, but this project is still alive, so we'll add more features. We have a roadmap, an open roadmap you can check in GitHub. So our goal is to establish the EOTDL, such as a Hugging Face for Earth observation. Yeah.
Do you have any limits for concurrency? And I have, because for Hugging Face, I have sometimes a problem that when I'm doing in 200 pods to initialize some weights from Hugging Face, I got too many requests. And what is EOTDL? There are some limits for concurrency, or no limits? Or what is the throughput?
So UTDL, the limits that it has, I think that currently it has no limits. Maybe only to upload datasets. I don't remember exactly the number of gigabytes or terabytes you can upload in the free tier. But for everything else, you don't have any limits. Also for the workspace, you have a GPU and 4 gigabytes of space in the workspace I show later. But for downloading, you don't have any limits. So you can, as long as you have capacity in your machine, you can go and download. We have some data sets about 500 gigabytes or even more. You can go and download them if you have the capacity for that. So there is no limit here. Okay, so we've seen how to explore and download datasets and models. Any features or any comment about the experience? So any feature you think, okay, I missed this feature for exploring datasets or for downloading them, or any comments there? Or where do you struggle the most where you are looking for datasets or for models? What would you like to see, or which features do you like when you're exploring datasets? Mhm. Yeah, you can do it through the CLI or through a Python library using the so you can check by a specific assets. It is described in the documentation. So there's no need to download the full dataset, but you can use this stack. Let me check. So here in this case, because the Eurosat RGB is just a zip, but if you have like a full dataset, actually this depends on how the dataset is ingested in the EOTDL. If you simply upload and ingest a zip file, you'll need to download the zip file because it's just a single file. If you do some work and the dataset is correctly curated, so you have different folders, directories, and so on and so forth, here, instead of having just like a single row, you'll have all of the items. So each file will be an item, and you will be able to filter and download by different items. Any questions, comments? Everything fine till this moment? Okay. So let's go to the next notebook, which is about ingesting dataset. So here what we can do is to ingest, obviously, if we have a local dataset or a model we've been working with, we can ingest it, upload it to the EOTDL, and make it public or not. We'll see later that we can create private datasets if we don't want to share our datasets or models and make them public. So in this notebook, we're going to showcase how to ingest an existing dataset into the EOTDL. So there are different options. We can ingest through the CLI, or we can ingest through the Python library. The recommended way to ingest a dataset is using the CLI. So as we've done before, we can go through the EOTDL datasets ingest command and use the help option. And here we'll have some information about how to ingest these datasets. So here we have the description. So this command ingests the datasets to the EOTDL. There are a few constraints when ingesting a dataset. So applying to the dataset name, so it must be unique, between 3 and 45 characters, and it can only contain alphanumeric characters. It must contain a README file containing some mandatory fields as some metadata, so the name of the dataset, authors, license, source, and the thumbnail. And the rest of the content of this README file will be used as a description of the dataset in the website. So here we have an example that I will see after. So the EOTDL datasets ingest, we need to give the path to the dataset, and here we have the different options. So for instance, if we want a verbose output, if we want to force it, if we want to ignore the stack catalog, if we want to make this dataset private, and so on and so forth. So in order to ingest a dataset, obviously you need a folder in your system with the data you want to upload. So here for this tutorial, we have the workshop data directory, where we have some files needed for this tutorial and as examples. So here we have some GeoJSONs that we will see later to create a dataset. And here we have a small version of the Eurosat, again, of the Eurosat dataset. This just contains some TIFFs with different annotations, with the README, and so on. So this is a small version of the Eurosat dataset that we have here for these demo purposes. So if we run the ls command in the workshop data folder, we'll see all of the examples that we have in the folder. And as mentioned, for this tutorial, we are going to work with a subsample of the Eurosat dataset. I think we haven't checked this Eurosat dataset, but the Eurosat RGB is a dataset used for land use and land cover classification based on Sentinel-2 imagery. Okay, so this is, if you want, you can go there. You can check the paper here in Archive. So this is, as mentioned, this is an image classification for land use and land cover dataset. So here, if we use Glob simply to show all of the images we have here, as mentioned, few images is just a subsample of the Eurosat dataset. We can check all of the images and files we have here in this subset. So the README file is required for the datasets and models, so it's mandatory to have this README containing some basic information. So if we run the cat command to check which is the metadata, we see the authors, we can see the license, the name. So here we can see this is name because obviously I did some tests before doing this tutorial, but here we can assign a name to the dataset, we can change it or we can play as much as we want. The only thing is that there can't be two datasets with the same name. So if I already have a dataset with this name, you won't be able to upload again a dataset with this name. You can change the name or you can add whatever you want. Here is the description, and if we want, we can change the README file with this cell. So we have here some code. I can change it to the name just to create another dataset. If we try to ingest this dataset again using the same name, it will use the versioning, as I mentioned before. But with that, what I will do is to create and change the README to ingest, like if it's a new dataset. I'll change here the description. And with that, so we have here this dataset. We can imagine this is our dataset and we want to ingest it to the EOTDL. We have the README file with this information. So it's as simple as running this EOTDL datasets ingest command. Here we give the path to the dataset. And with that, it will start ingesting and uploading the dataset. Obviously, the bigger the dataset is, it will take more time to ingest. But with that, we have ingested and shared our dataset in the EOTDL. So we can go there, we can go to datasets, and as we see here, this dataset is already uploaded and shared in the EOTDL with just a CLI command. So here we can check the authors, the description, the source, the different files, and the command to stage it. And we can go there, and we can also, the same we've done with the user interface, but we can check if we uploaded and ingested the dataset in the EOTDL using the dataset list and filtering by this name. And we can see that this is here. Okay, this is why I already mentioned that if you try to ingest a dataset with the same name I've used, you won't be able to do that. So you would simply need to upload a dataset with a different name. We'll see that even for private datasets is the same. So it simply will return a message saying that you can't upload a dataset with the same name. And the same applies for models. So during the ingestion process, as we've seen before, it creates a catalog packet file, which is a file created with stack metadata. So what it will do, if we go to workshop and we see our dataset, we can see this catalog packet file, which have been generated during this process. And if we want to open this dataset and show it like a data frame, we'll see what we've seen before. So it has created like a stack catalog with the different items and all of the files that this dataset contains. So we can go there and we can see all the files. So for instance, the README, the different TIFFs, the datetime we ingested the model, the dataset, sorry, and so on and so forth. So here we have the versioning. So by default, every time you re-upload a dataset or model, a new version is created if you add some changes. If not, the dataset of the model will remain the same. So if we create, for instance, a new file, so we can create a hello2 file, and we want to ingest again the dataset. We see here that it ingested the dataset, it uploaded the dataset to the EOTDL, and that a new version was created. So if we go there, we can see we have two versions. So we can go to version 1, where there is no changes, and we can go to version 2, and we'll see this hello2.txt file, and we can download it if we want. So this is about ingesting, and what we can do is to stage the dataset we just uploaded. So if we change the name and we do the same command we used before, datasets get and the name of the dataset we just ingested, we see that this is staged and downloaded in the default directory. And we can specify the version. So for instance, we can specify to the version 2, and we'll use only the version 2, and we will see here, and we'll see that we have here version 2. Okay, so as we've done before, we can explore the different versions of the dataset from the user interface. What we can do now? We can do the same we've done using the CLI, but through the Python library. So we can ingest datasets and models using the library, as we've seen before. Now in this notebook, we'll only see how to ingest datasets. In the final notebook, we'll see how we can ingest models, but the process is very much the same. As mentioned, we try to maintain the same logic. So here, we import the ingest dataset function from the Python library, and we simply use it with the path. And as you can see, as there were no changes between the current version of the dataset and the dataset which is hosted in the EOTDL, there is no changes, the dataset has not changed. But if we decide to create another file, let's, for instance, have this new file. If we want to ingest the dataset, we have another version. So if we go back to the user interface, we'll see that we have the three versions. So we have this third version of the dataset with this new file. So as mentioned, what this allows us is to come back. We can have a track of our dataset. We have, if we need to go back, if there is any issue or any error with the dataset, we can navigate through the different versions of the dataset. Okay, and this is everything. So we've seen how we can ingest datasets and share them in the EOTDL. How do you feel about that, about this workflow? Do you have any comments or suggestions for that? How to improve it? Are you missing something? Yeah. In the next notebook, we'll see that we can also ingest private datasets. So if we don't want to make our datasets or model public, we can maintain it as private.
What I would worry most is about just accidentally creating versions or stuff that are not necessary, and then just I don't know if you can remove them afterwards or there's some kind of maintenance. But if it's a notebook and you have some automated procedure, you might have some accident
Okay, so maybe you would like to be able to delete some versions if you accidentally ingest a version of the dataset. You like to be able to delete these versions.
How it is workable. If it is just through a website and you like check every click and make sure you upload, everything is slower, but it's more careful.
Mhm.
But if it's a notebook, or you give it to a collaborator, and then you really understood what's going on, run on, just uploading or changing something without really thinking about it.
Mhm.
So it's kind of, I don't know.
Okay. No, it's a very good feedback. So as mentioned, right now the EOTDL is not taking care of that. So this is responsibility of the users to make sure that they are using the EOTDL and the versions and so on and so forth. But it's a good feedback. So I understand that it's important to kind of maintain some kind of quality assurance before ingesting the dataset, right? So passing some checks or whatever you want to pass before ingesting the dataset, right?
Yeah, I mean, if it's not quite the same, at least to be able to correct these issues afterwards. Remove the data sets if some mistake has been made,
Mhm. Well, you can upload a new version of the dataset, but right now I think that it's not possible to remove like concrete versions of the dataset.
exactly, unless there is some kind of confirmation on
Mhm.
confirm you uploaded,
Mhm.
then it is kind of free for everybody. So you may have an accident of version 2 just because you run something empty,
Mhm.
empty because you just remove some files or whatever, and then you have version 3, the correct one that is.
Mhm.
So this is not exactly. It needs a little bit, I don't know, to be used carefully.
Mhm. Okay, no, noted. It's a very good feedback. Thank you. Okay, more comments or suggestions? Okay. So I think we'll have time for these two notebooks before the coffee break, and then we can go through the second part of the tutorial. Okay, so in this notebook, we'll see how the EOTDL works with a stack. So first of all, let's go to check the stack specification. So the stack specification is a specification that has arisen some years ago, and it has gained some good positioning across the industry, across the Earth observation industry. And it's a common language to describe geospatial information and also to access this geospatial information, especially for Earth observation data. I think that many of you said that you are already using a Stack, maybe using accessing data using the Stack API or simply serving the data using Stack or simply as metadata maybe? Or how are you using the Stack specification currently? Okay, I think that still shy. Okay, no problem. But the EOTDL uses the stack specification and is compliant with the stack specification. So you can use stack specification to query, and because the EOTDL serves everything using a stack API and generates stack catalogs. So you have not seen the stack specification. At the end, you have to think like different JSONs and a hierarchy. So first of all, we have the stack item, which is the core atomic unit. It can be a TIFF, for instance, a single image, or a band. Then we have the collection, and then we have the catalog, okay? So this is how this should be the hierarchy of the stack specification. And they are JSONs. So this is simply a JSON. You have different fields. That there are some fields that are mandatory to be compliant with the stack specification, such as bounding box, time. So I mean, obviously you need to provide some temporal and spatial information, but there are other fields and other extensions that are not mandatory. So you have to think as JSONs, and each JSON and the catalog can directly be linked to items or to collections and collections to items. So at the end, it's just like a hierarchy. So the EOTDL works with the stack, is stack compliant. And as we've seen before, when the EOTDL ingests a dataset, it creates a catalog packet with a packet file. Parquet, I don't know how many of you know what is the Parquet or GeoParquet file format? Okay, nice. So, well, for who are not aware of the Parquet format, GeoParquet is a tabular format, which is now very used in the cloud environments because it's very fast, allows a nice compression and quick access to all of this data. There are different formats which are or now considered cloud optimized geospatial format. We have GeoParquet. Now it's arising Iceberg. We also have obviously the cloud optimized GeoTIFFs. We have ZAR. We have different formats, and the EOTDL works with the Parquet file. So in this Parquet file, we have the metadata of the dataset. Here, this is a commented cell, so it's just to ingest again the dataset to create this Parquet file in case you haven't done it. But as mentioned, during the ingestion process, the catalog Parquet file is created. And if we go through the catalog file created using the Eurostat small dataset, we can see the different components of a stack catalog. So first of all, we have the type, the stack version, if there are extensions, date time of the ingestion, the ID, which is the name here of the file. Here there is no geometry, but we can check the assets, so we can check the repository. We can check some information from this dataset. And since the metadata generated by the EOTDL is stack compliant, it can be used. Here we have different functions to create and work with the stack from the EOTDL Python package. So I will run this. So here we have this geodata frame with the stack metadata, and we can create a stack catalog. And here we can see the different items from the stack catalog. Optionally, we can create a stack catalog or a collection and linking the items to this catalog. So here we created simply a stack catalog for this workshop using this Eurostat dataset. And even more, if we want, we can simply normalize and save this catalog here. And this is how it looks like. So in case you've never seen a stack catalog stack catalog, this is, as mentioned, simply a JSON with some information, the type, ID, and there we have the links. So we have the link, for instance, to the catalog to itself, and the links to the different items. So it can be to the README, it can be to the TIFF. So all of this information, this is. Check.
I think the item is the whole product of observation, and the single files are assets. At least in stack naming, this is called. If you go on single file level, it's asset, not the item. Item is a whole product.
Yeah, well, here in the EOTDL, this is the nomenclature we use.
The definition is quite wide. If you look at the UML schema, it's a chaos. So
Because I was more familiar with it, asset is a.
usually items are actually package of plans and whatever assets actually, but as I was saying, it's not that clear.
You search on item level, it's usually is a product.
Usually, generally speaking, yes. At least in CDSC stack catalog, the common understanding is that if you have a sentinel-2 item, you are referring to a specific data, bit, and within that item you have all the bands in it or all the other components of the package. What in the past was the SIF directory, okay?
That's a problem of stack. Whoever is able to
Yeah, so exactly as he said, so this is kind of flexible, and we decided to use the stack specification in that way.
Okay, because in Cloudflare we are doing this new stack catalog for Copernicus, and maybe it would be good to align naming the same names for everything.
That is the problem with it, but like you can always name also your items by the events, but it's not pretty good practice.
At least for newcomers, it might be confusing. That what is item here is asset here or something like that.
if you are interested, we could organize a software. I think that it could have a really lot of attraction to people that are doing Copernicus.
Also, I think there is the, I don't know if you use Slack, but this is the Cloud Native Geospatial Slack channel, where there are a lot of discussion about this there. So it could be a good point of communication to kind of align all of these thoughts. Okay. What else? So, as mentioned, the EOTDL, you can interact with the EOTDL via its Stack API. So, for instance, we can interact using the CLI, so we can do EOTDL stack help command to get the information of the different commands that we can use to interact with the stack API of the EOTDL. So we can check the status, check collections, items, or search. Here, for instance, we can explore the different collections of the EOTDL. So here a collection is simply consider a data set. So we have here the different data sets we have in the EOTDL. And we can do the same using the Python library. So we can work both the same using the CLI or using the Python library. So we can retrieve stack collections using this function from the EOTDL Python package, and we can do the same. So we can check, we can get all of the different data sets with its ID from the Stack API. And obviously, we can filter by the name of the collection. So we provide this name, it will filter by the name of this collection, of this data set. And here we'll get all of the information of this collection, of this data set. So the author, the license, the source, and so on and so forth. So the metadata itself of this data set. We can retrieve it as a stack collection, so the same we've seen from the Python, from the CLI using the Python library. So this is exactly the same, all of the metadata, but following kind of the stack format, stack collection format. And here we can search by items in the Stack API. So we can do, again, the same, working with the CLI or working with the Python package. So we can have all of the different information here. For every item, we'll have the reference in the API, and so on and so forth. So we can do the same using the CLI or using the Python package. And we can retrieve per item. So we use EOTDL stack item, the name of the data set and the name of the item, we can retrieve information for this item. The same for the CLI and the same for the Python library. Another option we can do is to also search using SQL queries, using DuckDB. How many of you know about DuckDB? Okay. Well, DuckDB is an in-process database that lets you run fast SQL queries directly on local data without like a server. So it's perfect for quickly filtering and exploring. So as always, we can use the SQL queries using the CLI. So we can run EOTDL stack search, the name of the collection, and the query flag, the query option, and some SQL queries. And with that, what we'll return is, with a SQL query, we'll get the information from these two items, from the README and from the forest retrieve, using a SQL query. And we can do the same again using the Python library, so exactly the same. And here, sometimes if you don't know which filters you want to apply, if you use EOTDL stack search and the name of the dataset of the collection, you'll get which are the different kind of filters or parameters you can use to filter. So for instance, the stack version, by extension, by datetime, by ID, bounding box, and so on and so forth. And the same using the Python library. And yeah, so I think this is time for the coffee break. We have still some notebooks to go through, so I think we are good on time. So I think it's 30 minutes. Any comments or suggestions until this point? Everything fine? Okay. So see you at 11. I think it finished the coffee break. Okay. Welcome back. It's a bit sunny there. So. Okay, so let's assume where we left. It's more or less where we are still to see 4 notebooks and the Scaneo, another tool. So this part of the tutorial is until 12:30. Maybe we finish earlier, so I'll give you freedom to go to the lunch break. So let's go with where we left. We were talking before about, we've seen the EOTDL platform, we've seen how to explore the different user interfaces, graphic interface, the CLI, and the Python library. We explore datasets, we explore models, we have ingested datasets, and we've seen the stack specification and how the EOTDL uses the stack specification. And now we are going to see how to work with private datasets or models. Then we'll create a small dataset and we'll label it. We train a model and we'll ingest a model. Okay? Before continuing, anything you want to share, comments, or whatever you think would be relevant? You're still shy, okay? Okay, so last part about ingesting datasets and exploring datasets is to check the capacity or the feature of EOTDL of having private dataset. Okay, so by default, all the datasets and models in the EOTDL are public, but however, you can create private datasets and models that only you can access. So it's very easy, it's just that at the ingestion time, you need to specify with both in the CLI or using the Python library if the dataset or the model should be private or not using the appropriate function. So what we can do here, as we have here in the workshop data folder, we have the Eurosat small dataset. We are going to copy and we create a different folder and we'll name it Eurosat small private. I'll give it another name. So here I'm creating a metadata text for the Markdown, for the README, with a name for this private dataset, Eurosat small bits private, author, license, and source. And here I will copy the dataset and we create the README. So here we have the same dataset, but with another name, and also the README is different. And now I can ingest it using the CLI. And this is important here, we add the flag PR, which is private. So with that, I will ingest this dataset, this private dataset, into the EOTDL. So, as it's a small dataset, it won't take too much time. And it's ingested. So if we go to the EOTDL, I can go with my account. And if I check here, private, I can see this is another dataset I use for testing purposes. And this is the dataset I just uploaded. If you go there to the EOTDL, you won't see these datasets, or at least you are not supposed to see these datasets. So this is a feature where you can store and host private datasets or models in case you simply don't want to share them or you want to maintain them private. You can do it using this flag in the EOTDL. And the same applies for models. So this is how we can do it using the CLI, or we can do it using the Python library. In the ingest dataset function, we can use the private parameter. We can set it as true. If we run it, it won't ingest anything because the model is the same, and because the dataset is the same, nothing changed. as here, no new version was created, your dataset has not changed. But if we change the dataset, it will, as we've seen before, it will update the dataset and will create a new version. So in order to retrieve these private datasets, you need to be authenticated. And if I check here, if I use the retrieve datasets function to retrieve all the datasets, and I check if the Eurosat dataset we just ingested is in this list, we'll see that it's false. So by default, the private datasets are not retrieved using this function. But instead, we can use the retrieve private datasets, and this will return all of our private datasets. So as we see here, we have all of the private datasets we have ingested. And we can see here that the differences between listing all the public, by default, all the public datasets using simply EOTDL datasets list. But we can also add this private option, and this will retrieve all of our private datasets or models. And the same, it is the same if you want to stage the dataset, you simply need to select here the number of the dataset, a path, an output path, and it will stage and download this private dataset. You can only download the dataset if the dataset is owned by you. If not, you won't be able to stage the dataset. You can do the same as always using the Python library. And that's all for this part. So this is just how to show that the EOTDL is able to manage private datasets. One question I want to ask, I think that's something that arose before, that about the interest of having private datasets. How do you value your privacy here? Do you mind opening your datasets, your models, or do you prefer to having them privately hosted? So I assume that maybe if you work, I don't know, in under a ISA or ISA program, maybe you need to open, or you should open the datasets, or you are a private company, obviously you want to protect your IP, so you want to keep them private. So I think it will depend on, we assume that it will depend on the use case, or your company, your policy, and so on and so forth. So at the end, that's why we decided to add this option, because it's something that in previous workshop, it also arises that not everyone wants to share the datasets. At least, as mentioned, creating datasets has a lot of effort, and you put a lot of effort, and maybe you don't always want to share this effort for free. So that's why we offer this opportunity. Yeah.
So I guess that it's not necessary to ingest this data. I mean, we have local data, the data, and we have the models, and how they are. Can it be used directly, or it has to pass through this procedure of ingesting it so that it can be processed by models?
So if you have your dataset and your models locally, there is no need to, if you don't want, you don't need to use the EOTDL. So if you prefer, you have your on-prem capacity, you have a lot of GPUs or hardware to store your models and datasets, it's your decision. So we provide this tool, but it's your decision if you want to use it or not.
So then we can use the workspace and etc. Having them uploaded there. So that's useful.
Yeah, exactly. But I mean, there are different companies. For instance, we have our own machines, our own servers. We use obviously the EOTDL, but depending on the situation, we use the EOTDL or we use other machines because we have the servers and so on. So this depends on the company and depends on the strategy of the company. If you have 40 terabytes of capacity, you are lucky you are lucky to be able to manage that. If not, there are these kind of solutions. Okay, so let's go to create a small data set. Probably this is a most interesting part where you'll see different EOTDL tools to create a new data set. So here we'll cover data exploration, data access, and data preparation. Okay? So later on, what we'll do here in this session is to create the dataset, download some Sentinel-2 imagery from our area of interest, creating a bounding box and so on. We'll download the imagery, we'll label it using Scaneo, which is a tool I'll show later, and then we'll ingest this dataset. Okay, so first of all, what we can do is to select an area of interest. For this use case, for this tutorial, we selected the Boadella Reservoir, which is a water body in Catalonia, Spain. We work a lot here, and we always use this as an area of interest. So we have in the workshop data, we have the GeoJSON with the area of interest, and we are going to use LeafMap for visualizing the area of interest. I don't know if you know what is LeafMap, but well, it's a Python package that allows us to do some nice visualizations on a map. So here, for instance, this is the Boadella new reservoirs here in Catalonia, and we can use LeafMap to simply visualize this GeoJSON. There are a lot of different tools with this Folium. I think there is also EPI, Leaflet, so there are different Python package, but we decided to go through this one. Okay, so you may know that when working and when creating datasets, it's usual to work with a fixed resolution. So you can retrieve like a full scene of, for instance, Sentinel-2 and cut patches, or you can use the EOTDL functionality to generate the appropriate bounding boxes. So here, with the aim that all of the images in the dataset have 512 pixels per 512 pixels, we are going to use the centroid of the area of interest that we extracted before from the GeoJSON. We generate a bounding box with that, with a pixel image of, again, 512 and 512 pixels, and a 10-meter resolution, okay, since we are going to use Sentinel-2 data. So here we can get from the tools module of the EOTDL package the function bbox from centroid. What we are doing here, previously, we calculated the centroid of the area of interest of this GeoJSON. We get the coordinates of this GeoJSON. And here what we are simply using is, giving as parameters, is the coordinates of the centroid, the pixel height, the width, and the height in pixels. And this will retrieve this bounding box. And we can create a bounding box, a polygon from this bounding box, again with this function from the EOTDL from the tools module, which is bounding box to polygon. It simply gets a bounding box and creates a polygon. And we can display this bounding box here in the map. So this is the bounding box we are going to use to download the Sentinel-2 imagery. Okay, now that we have the desired bounding box, we can look for available Sentinel-2 imagery there, and this can be done through the EOTDL. So first of all, we can take a look from the access module from the EOTDL, which are the supported collections, which are the sensors that we can get from the EOTDL. Here, as we can see, we have at this moment Sentinel-1, Sentinel-2, both levels, them, the harmonized, and Landsat. And now what we can do is to take a look on the available Sentinel-2 imagery in our area of interest. So for do so, we must define a range of dates in which we want to search for the image. So we have already defined a time interval in this workshop. So we can go to the workshop data dates CSV. So it's a CSV where we have stored some dates. So it's simply, you can simply import the CSV package and read this CSV. And here we have a bunch of dates from the 2020 that we want to explore the imagery. So, something important before going to the exploration is that, as I mentioned before, Synergize is part of the consortium of the EOTDL, and so the data access is managed through Sentinel Hub. So the EOTDL uses Sentinel Hub under the hood, so you need to provide the appropriate credentials. You can generate them from your user profile in the user interface by accepting terms and conditions and so on. So if you go there, you have to accept all your terms and conditions. And if you go to credentials, you'll get all of the credentials for the different services for the EOTDL. And one of them are the Sentinel Hub secret ID and secret access key that you will need to add to be able to explore and download imagery using the EOTDL. So something important is that if you already have a Sentinel Hub account with the same email as your EOTDL account, you need to retrieve the credentials directly from this Sentinel Hub dashboard. And if not, you can do it using via EOTDL. And what you need to do is to put them here in the repo. We have this emp.example file. Here you should put your client ID and your client secret. So now that we have these Sentinel Hub credentials up, what we can do is go through the access module again and use the search Sentinel imagery. Here we're going to simply put a time interval between two dates, and we're going to search the imagery through the time interval, through in this bounding box, and in the Sentinel-2 L2A collection. And here we are simply showing a part of the response. So we have some images, we have the ID of these images, we have the properties such as the date, the cloud cover, and so on. So some information for these images. We can go there and we can print the full number of dates with available images in the time interval we selected. And here, now what we can do is to download. So first, we explored the available imagery in this area of interest. And now what we can do is to download to start creating our dataset. So the next step is to download the images. On the one hand, you can download image by image, as you can see here. So you can get the first date. And using the download Sentinel imagery function, you provide the path, you provide the date, the bounding box, and the collection. And this will start downloading the image. So if we go to data Sentinel-2, we have here this TIFF. If we open QGIS, we can take a look on that. And this is the image, Sentinel-2 image. Obviously, the bands are not correct because this is downloading all the bands from Sentinel-2, so we need to rearrange, change the RGB and match the bands and maybe do some clipping to make sure the visualization is correct. But here we can see that we have downloaded the TIFF, the Sentinel-2 image, using the EOTDL. So this is to download just one image. But what we can do is to download all the images in a certain time interval. This is like the bulk download. This is the recommended way if you want to download everything from this time interval. But the drawback here is that you can't control the quality of the images, as for example, by the cloud cover. So right now you can filter using cloud cover. But here what we are going to do is to download a bunch of dates. It may take some time, well, 5 seconds. If we go back there, we see that we downloaded 5 lot of different images. And again, we can go to QGIS, for instance. This is full of clouds, but we can see the different imagery that we downloaded using the EOTDL. Okay, so this is, we can check the quality of the images in your preferred way. So I like to use QGIS because I'm very used to to that, but there are tools for visualizing the raster here. So obviously, PyPlot, Matplotlib, or Xarray, or whatever you prefer. So there are different visualization tools. Right now, one library that it's quite nice is HoloViews. I don't know if you know it, but for kind of plotting rasters in an interactive way, it's quite nice. So it's beautiful, especially if you don't, for instance, in my case, I work with remote servers and I can't be continuously downloading locally the images, so it's a nice way of visualizing the images. But when I have it locally, I like to work with QGIS. So as mentioned, you can use your preferred tool. So last optional step is to rename the images and clean up the directory. So here we are simply going to rename them. Okay, I missed this point. So here we are renaming the images, and we have here beautiful name. So the name of the area of interest, Boadella, and the date. So as a final step towards creating the dataset, there are multitude of tasks, obviously, that can be performed. So data cleaning, feature engineering, data analysis, labeling, and so on and so forth. For each one, you can feel free to use your favorite tools. Here, what we are going to do in this tutorial is to demonstrate labeling using Scaneo, which is an application developed under the EOTDL framework. Okay, so what's Scaneo? Scaneo is a labeling web application that allows to label satellite imagery. You can have a bunch of images. You can label them for different tasks, such as for identifying objects, segmentate, classify, or whatever you prefer. And this is a web application that you can use, and it's very easy to use. And the most important part is that it's focused for Earth observation data. There are different tools that you can use to annotate images, but not all of these tools are focused on specifically designed for geospatial data and for Earth observation imagery. But Scaneo is designed in that way. So before running the web interface that you will see is very easy to launch, first of all, we need to add the Scaneo package, which is simply another, again, a Python package. You can do pip install Scaneo or uv-add Scaneo, so whatever you prefer. Before starting, this is the GitHub of Scaneo. So all the tools we are showing, also PyTorch that we show later, are open source. So please, this is the GitHub. Feel free to come here, create issues or see which are the current issues. Maybe you want to contribute to the code base or whatever. Please feel free to come here and play around. Here in the GitHub, obviously, we have the source code, and again, as we saw before for EOTDL, we have the context or why to use Scaneo, why it was developed, how to install it, how to use it, documentation, we'll see now, and so on and so forth. So, first of all, we can check what we can do with the Scaneo command. So we have different options. We'll see that it's very easy to launch the Scaneo, but we have different options. We can change the port, we can change the host, the number of workers, the version, and so on. So there are different options. But running Scaneo is very easy. It's just about opening the terminal or running here, if you prefer. And with that, we'll open the graphical interface of Scaneo. Okay? This is the landing page of Scaneo. As mentioned, this is a web application to label using AI the images and the datasets in a very, very quick and fast way. Okay? There are different features. I don't know if you will, I'll give another workshop this afternoon about the Scaneo, which will be more focused about the AI capabilities of Scaneo. I won't cover them here, but in case you want to take a look, feel free to come later in the afternoon. So here there are some of the powerful features of Scaneo. So for instance, the AI-assisted labeling, because we can connect Scaneo to an inference API and let AI label the images automatically. We can manage different label campaigns. We have multiple adaptation types. Obviously, we can export the labels we create, and we have different plugin ecosystem. So this is the landing page. Here, we can go to the GitHub. We can see how to contribute. So this is something we already seen. We can go through the documentation. This is a bit of getting started and how Scaneo works. We'll see it now. So we can see how to install it and how to run it. But what we can do now is to create a campaign and label the images we downloaded before. So we can go there to campaigns. We can delete this one, this old one, and we can create a new campaign. A campaign is simply like I want to label a data set or a project or whatever. We can manage it through campaigns. So we can go there, create a campaign, assign a name. Description. Here we can select the storage. There is a plugin that we'll see later because we can directly label datasets which are hosted in the EOTDL. We can set a local storage, and the S3 storage is still to come soon. So we want to let users directly connect Scaneo to a S3 bucket where they have their images. But now we are going to select a local storage. So we need to know the path. Give me one moment. It's data sentinel2. Okay. Okay, and what we can do now before creating the campaign is to already create some labels. So for instance, we can use this dataset to create a dataset we can train this dataset for water masking and for segmenting water bodies. So we can add the label and create the campaign. Okay, and now we can go to label. So this is the user interface of Scaneo. As mentioned, it is specifically designed for geospatial and for Earth observation data. Right now, it has only support for TIFF files. We'll work to add more file types such as PNG or other Earth observation files type that users use. But right now, it has only support for TIFFs. What do we have here in the user interface? Obviously, we have the map, which is the most important part. Here in the right, we can check if we want to hide the bounding boxes or not. We can reset the map. If we move and we want to go back to the center of the map, we can do that. And here we have the images. So we can click, and we'll display the different images that we downloaded before. Okay, here we have the different labels we created, so we can create new labels, for instance, for forest. And we have forest and water. Here we'll see the annotations we create. So we don't have it yet, but we'll have in a couple of minutes. And here we have some visualization settings. So as mentioned, as said before with QGIS, we needed to rearrange the bands and to adapt the stretch. So here we are using the RG bands from Sentinel-2, 432, and we are adjusting the stretch to 0 and 4000 to make sure that the visualization is correct. Okay, so now what we can do? Which are the different tasks that Scaneo can label? First of all, we have classification. So if we want to say, okay, let's imagine we have the Eurostat dataset and we want to say this image is a forest. So if we want to label this image as forest, we need to set the label and assign the classification. And if we go there, we see, okay, this image has been tagged with the classification type as forest. But we can delete this tag. What else we can do? We can create some detection annotation. So let's imagine Here we have some buildings, so let's create another building annotation. So here we can go and draw. Obviously, this is very coarse, but if we wanted to create this dataset for building detection, we can go there and we can start drawing buildings. Can be buildings, can be ships, can be whatever you want. So you can go here and you'll see all the annotations we created for this image. Again, we can remove them, right, quite a few of them, sorry. But what is the purpose of this dataset? So we said that we wanted to create and label this dataset for water mask segmentation. So we can go through segmentation. I select another image. Yeah, this for instance. So we can select the segmentation tab, select water, and here we can draw. So what we can do is to obviously adjust the size of the drawer, and we can start drawing here. Obviously, this is, you can allocate as much time as you want here, so the better you create the annotations, you already know, the better will perform the model, but this is just to show a bit how we can run and we can use this segmentation annotation. So with that, we can go image by image and continuously label the image. Okay, so what we can do now? Let's imagine we finish the dataset, it's okay, we can adjust the, as mentioned, the drawer here to the drawing pane. If we want, we can correct. So we have different drawing options to make sure the labels are good. And what we can do now is to export this labeling campaign. So we can go here, click export, and say your annotation will be exported at the same folder where you have all of the images, you have 5 images, you have 8 annotations, and say, okay, export campaign. So if we go back to the folder where we have all of the images, we see that per each image with a label, we have a GeoJSON file. And here what we can see is that we have this GeoJSON file, we have the features, the feature collection, we have the features, we have the geometry, and also we'll have the different tasks. Here, if we go to properties, we see that we have different labels. One label is water, and the task is segmentation. But we can have different labels and different tasks for the same image. So this is just an example. And we have this for every image where we have a label. So it has the same name as the image. Now, as we see, your annotations are stored alongside the images as GeoJSON, so we can go there, and we need to stop the server. And if we go there, we'll see the different annotations we created using Scaneo. So now that your data is ready, you can ingest this data set like we've seen in the previous notebooks. So we can create a README file with Boadella. We can assign a name, Boadella water bits, author, license, source, and some description. With that, we'll create the README file alongside all of the images, all of the labels, and so on. And we can ingest this dataset. As we've seen before, we give as path this directory, and this is ingesting all of the images and the labels to the EOTDL. So we go to the EOTDL. Here we can see the dataset we just uploaded. We can check here all of the images. Yeah.
Haven't you
You can do it. So as long as you follow the same format, so it's a GeoJSON with the properties and the task, you can do it. So you can export your own labels. So if you get the geometry and you create the GeoJSON and you put it alongside the images, you can then edit it. So you can do it, you can export. It should be kind of Scaneo compliant, but at the end it's just following this format, but you can do it.
But eventually it might be good to can sort of import Scaleo to
Online,
to
like
redo,
at the bottom.
yeah, to redo some tasks.
So exporting directly from OpenStreetMaps, you mean?
Yeah, exporting from opening from Osmo, importing Scaleo to get rid of redoing some tasks that are repetitive.
Okay.
That are important to be in the training set.
Okay, so avoiding this intermediate step of creating the GeoJSON, but directly from OpenStreetMaps, importing the labels. Okay. Okay. No, that's a very good feedback. Okay, thank you. Okay, here, as we've seen before, it created a catalog Parquet file with all of the stack metadata. And this is how we can use Scaneo. So Scaneo, it's still, again, under development. Powerful feature that it has is that you can connect Scaneo with an inference API, and you can automatically label the images. This is something that we'll see this afternoon. So for instance, if you have a model to detect clouds or to detect roads, so to segment roads or clouds, it can automatically label your data set. So this is a feature that we'll see in the afternoon. Here, there's much more that we can see in the EOTDL. So we have in the EOTDL, also in the GitHub, we have different use cases that you can check, which are the use case A, B, and C, which are different use cases that are using tools from EOTDL with advanced features for feature engineering and so on. So in case you want to see more of that, you can go there and you can check different use cases. So for instance, I think they are pretty much based on the Satellogic dataset. But for instance, here in the use case B, we can see how to leverage EOTDL functionalities using to create a dataset and a model for super resolution. So it starts using the Satellogic dataset, which I don't know if you are aware of this dataset, but it's amazing dataset released from Satellogic with, I think, millions of images from Satellogic free to use. So one good use case is to use this dataset to create a super resolution model. So here, what we are doing in this use case is to get this dataset from Satellogic, then downloading the data, pairing the Sentinel-2 matches, creating the dataset, and then training the model. As mentioned, this is something that, if you want, you can take a look on how you can use the EOTDL for different specific use cases. So this is the use case B for super resolution, but we have also the use case A, which is for unsupervised learning, and you can go also to the use case C, which is to create a data set and machine learning models for multitask learning on super resolution imagery. So these are if you want, if you are curious, you can take a look on the different notebooks we have here for these three use cases. And you want to learn more about the different functionalities of the EOTDL, like in an in-depth point of view. Okay, so this is about this section. Tell me, what do you think about what we've seen about exploring data, downloading data, and Scaneo? What do you think about that?
I have a question regarding Scaneo.
Yeah.
Does it only work for RGB, or can we also use like hyperspectral data in order to label it as well?
For Scaneo, you mean?
Yes.
I think that it's just like Sentinel-2 imagery at this moment. But if there's something that is interesting, we can put it in the roadmap. So as said, we are gathering input from users, and if we see something interesting, we can add support for that kind of data.
Because it would be great if we had also labeling for spectral or multispectral images, not just RGB.
Well, I mean here, sorry, I need to relaunch. But here, as I mentioned, you can use different bands. So it's not about RGB. So here we use RGB kind of for visualization, but you can change the bands if you want. So, but that mention is just for Sentinel-2 at this moment. So it just supports Sentinel-2 imagery.
About this, you just loaded some local tip files.
Mm-hmm.
Nothing about Sentinel here, right?
About what?
There's nothing about Sentinel unless there is some kind of metadata that is used. But implicitly, it can be any kind of tip image that has the correct format.
I don't understand. So what do you mean?
What I'm trying to say, if I have a tip file from different cellular from whatever, would still work. It's still annotated.
Yeah. Yeah. So you can upload any Sentinel-2 image or TIFF or whatever. Yeah. You can do it.
Yeah, but it can be a non-Sentinel image.
At this moment, not. Sentinel-2. Yep. Okay. Anything else? More comments there? Okay. Which tools, if may I ask, which tools do you currently use when you create your datasets and you want to label them? So maybe QGIS or something similar?
I mean, at least some time ago, there was a tool called Segments AI, which actually no sort of idea-wise looks very similar to this Scanio. I think recently it got called into the paid mode, so it's only free.
But does it have support for geospatial? So it supports the geospatial component and the coordinates and so on?
Yeah, I think there was support because they were blocking cloud mask and like all the labeling was done in that tool.
Segments AI.
Yeah.
Okay, I'll take a look. Any other tools that you used before? Okay. So I'll close this. Okay, so now we go through training a machine learning model and ingesting it. So we are facing the end, the last part of this tutorial. So let's imagine now that you have your training data set, or you find a useful data set in the EOTDL, or you created your own data set. Now what you can do is to train your model, obviously. Here in this example, in this notebook, we'll show how to use the Eurosat, again, the Eurosat dataset in the RGB version. But something important is that here we are not going to show how to train, like they actually train a machine learning model, but how we can use PyTorch, which is something we'll see later, to train AI for your models and so on. So this is one thing I wanted to add. So here, first of all, what you can do is to obviously download the Eurosat dataset. So as we've seen before, using the stage dataset function, we start with that. We want to use the version 1. We want to store it in the data folder, forcing to download and downloading all the assets. So here we have just downloaded the data. And what we can do here is to unzip the zip folder where we have all of the images. This may take some minutes. Oh, no, okay. Okay, so now if we go to data Eurosat, no, here, data train, we have the Eurosat RGB dataset stored locally, and we can use it to train a machine learning model. Okay, so here we are going to see another tool across the EOTDL environment, which is called PyTorchio. PyTorchio is an open source library which is built atop of PyTorch and PyTorch Lightning, and is especially focused for training Earth observation models, AI models for Earth observation. So this library the goal is to facilitate the design, implementation, training, and deployment of deep learning models for Earth observation. So as mentioned again, here our goal is not to provide a complete tutorial on how to train a model, but rather how to do it using the EOTDL and how to do it using PyTorchio. So we can go there, and as mentioned, all of the tools that we show are open source. So this is the GitHub of PyTorchio. Here we have the source code of PyTorchio. We can see how we want to install it, how we can install it. We have some examples, so we can go to the example folder, and we have a lot of different notebooks using different data sets and how we can train models for different tasks using this PyTorchio Python library. And again, tutorials, some challenges where PyTorchio has been used. So for instance, Eurovia on Cloud N also are panel detection. So these are some challenges where PyTorchio was used. And this notebook, we are going to use also PyTorchio to train a model using the Eurosat RGB. So here we have in PyTorchio, we have a wrapper to download the datasets. Here we set the download as false, because if we set it to true, it will download again the dataset, and we already did this using the EOTDL. But running this cell, we'll get the dataset set up with the number of images, training sample, validation sample, and test samples. So we can get the data frame from this dataset, and we can see that for all of the images, which labels we have. We have different labels across 10 categories, from manual crop, forest, herbaceous vegetation, highway, and so on. So different land use and land cover classes. But before training, what we can do is to visualize these images with the labels. So here we have simply some code to go through the data set and plot the images. So for instance, we have images, again, for classificated, such as forest, sea lake, river, residential, so different use cases. And what we will do here is to use an image classification task, which is already included and integrated in PyTorchio, to train this model. So here, what we are doing is to define this task, which is the image classification. We are seeing here the shape of the output. And now that the task for classification is defined, we can train the model using Lightning. So here I won't go through the full code, but what we are doing here is to train the model. We can select between CUDA if we have GPU or directly CPU. We can change the number of epochs. So the more epochs, the more it will take training. So in this case, I won't run it because it will take like a lot. But here we have some information and the result of this just with for one epoch, some results here of the model. And once the training is complete, what we can do is to evaluate the model, which is the test set. So here we are using this package. Is called TQDM. It's quite nice if you want to track the monitor how it's going with a loop or whatever, you can use this package. But here at the end, what we'll do is to test the accuracy of the model. But the best way to do so is to visualize the predictions on a random batch from the test set. So again, here we have some code, and the model train, and we'll see how the model differentiates between the different land cover classes. In green is where the model actually predicted the class, and in red is where the model was wrong. So obviously with one epoch, the model can be much more improved, but this was just for tutorial purposes. So here we have this visualization, and what we can do now is to export this model, save it as an Onyx file. You can use your preferred method, but here we use the Onyx file. So to install and to be able to save this model as an Onyx, you'll need the Onyx and the Onyx runtime packages. And here we are simply selecting the path, and we are saving this model to an Onyx file. So now that we have this Onyx file, which I'll have it here. So this is how it will look like. So an Onyx file where we store the model. And what we can do is to, here what we are doing is to read the model and testing it to make sure it works and testing some accuracy. So this was just to train the model, and later on we'll see how we can ingest the model. But this was a showcase on how we can use PyTorch for different tasks for training AI models over Earth observation data. If we go back to the GitHub and we go to task, here we can see different tasks that currently PyTorch has support. So right now support for classification and for segmentation. Again, we are working on improving it. If you have suggestions, if you want to contribute or whatever, if you want to use PyTorch, play a bit with it and try it, you have the issues. You can create issues. And again, here we have the tutorials where you can go through to see how to use Scaneo, load data, creating data sets, and the different tasks, and some examples on how we can use PyTorch to train using different data sets. So for instance, we have for the Big EarthNet, Notebook, Eurosat data set. So we have Sen1 Fluid. So we have different data sets and different examples here if you want to take a look later. Okay, so this was about training. Any comments there about that? Which are the libraries you are currently using for training your models? Maybe Torgeo, Stickit. Still shy, okay. Okay. And the last that we'll see here is to how to ingest an existing model into the EOTDL. Yeah?
I have maybe a dumb question because I'm not an expert working on this, but this PyTorch is flexible enough for selecting different type of models and customize and fine-tuning them, for instance?
This is a very good question. Actually, this library was developed by my CTO, so he's the one who can ask you. I'm sure he's working on that. Maybe this can't be supported right now, but in the future we'll expand it to make it possible. It's something I cannot ask right now. Okay, so last step here is to ingest a model. So we've seen that we train a model and we create the Onyx file and so on. So that we can do, as last step, is to ingest this model through the CLI. So as we've seen before, the nomenclature and the syntaxis is the same for datasets. Here we can use the CLI to ingest this model. So we can use EOTDL models ingest help to get the help and some information about how we can ingest and upload the model to the EOTDL. Here, what I can do is to move to data the backup. Yeah. So let's imagine that we trained our model before. I didn't because it could take quite long, but here we have our Onyx file. And what do we need to ingest this model into the EOTDL? So obviously, first we need to create the README. So we can use this cell to create the README. So we are assigning a name to the model, there was at RGB bits, some description, metadata, and so on. We are creating the README file, and now we can simply ingest it. So as we've seen before, EOTDL models ingest, we give the path to the model, and with that, it will prepare and will ingest the model into the EOTDL. So if we go to the user interface, and we look for bits, here we have the Eurosat RGB bits, which is the model that we just uploaded before. We go there and we use the functionalities we've seen before from the CLI. We can retrieve the list of models. Again, we can see we can use the versioning. So if we change anything in the model or in the folder, the EOTDL will take care of the different versions. We can download the model again if we want. So everything that we've seen for datasets can be done the same for models. So here we are simply getting the model. We are saving it in the default directory, but we can change the path, and we can play the same we've seen before. And obviously, we can ingest the model using the library. So everything that we've done using the CLI, we can do it through the library. And that's all. So as mentioned, the pipeline to ingest models and to ingest datasets, it's pretty much the same. So we wanted to maintain it in a logical and established way. So that's why we tried to keep it simple. What do you think about this? Do you think this workflow can be improved for ingesting models, or are you happy with that? Yep.
This version control system, this is just a number, or we can have better versions, etc.?
It's just a number, so it's 1, 2, 3. Yeah.
Because that would be an improvement, just when multiple people are contributing to the model, to have these CPA phases, but this can be also like forking. Like you have version 1, but then you have the 2B. That can be supported, it's going to be better to work with these models rather than working locally and something works and then saying, okay, now let's ingest.
Okay. Yeah, so working with kind of branches or dep branch or dep version or something like this, or with tags, alphanumeric tags, or yeah. Okay. Noted, thanks. Okay, so that's all for this tutorial. We have, 20 minutes still, but I'll give you freedom to escape. So this is just the last notebook if you want to get involved in the project. As mentioned before, you can join the Discord server. Here you have the link. Here in this Discord server, we share updates, new data sets, or wherever it's related to the EOTDL. Or you can also engage in GitHub and add issues or pick issues or do whatever you want if you want to contribute to the source code. Here we have this QR, which is for feedback for the EOTDL. So this is a short survey. If you want to participate, we'll really appreciate it. Okay, it's short survey about features from the EOTDL and so on. And here we have some ways on how you can contribute. Obviously, you can upload your datasets and models, which is the most straightforward way to contribute to the EOTDL. Then you can build third-party applications. You want also to contribute, or you can contribute directly to the code base, pick issues, find bugs, or this kind of developer stuff. And here we simply have some guidance on how you can run the EOTDL locally, but I won't go through in depth for that, so you have the instructions here in case you want to contribute and you can to deploy and develop locally the EOTDL. So yeah, so that's all. Thank you very much for attending this tutorial. I hope it was interesting, and see you later.